All right, so part two. So we have three more parent functions that we got to talk about. So we've gone through four. The next three, these are the ones that I'm anticipating us being a little less familiar with. So let's start with, what number is this? 5? All right, so 1 over x is our next parent function here. All right, so this one's a little bit goofier, but I think once we make a table, you guys might recognize this from last year a little bit. So again, let's go ahead and throw in a couple negative numbers, 0, a couple positive numbers, and let's see what happens here. All right, so plug in -2, I get -1/2. Plug in -1, I get -1. Plug in 0, I get, undefined. Because 1 over 0, that's undefined. Plug in 1, I get 1. Plug in 2, I get 2. Alright, oh, that's not true. Plug in 2, I get 1/2. So let's kind of throw these on a graph and just kind of see what's going on here a little bit. So plugged in -2, I got -1/2. Plugged in -1, I got -1. 0 is undefined. Plugged in 1, I get 1. Plugged in 2, I got 1/2. I might need a couple more values here. That's just not really helping. If I plug in 3, I get 1/3. So it seems like this part of the graph is getting smaller and smaller and smaller. If I plugged in 4, I get 1/4. Plugged in 5, I get 1/5. If I plugged in 100, I get 1 over 100. So this part of the graph looks like it's getting closer and closer to 0. Not sure if it's going to touch or not. We'll have to figure that out. What about in between 0 and 1? So if I plugged in like 1/5, let's say. So what would happen if 1/5 was my input? So it'd be 1 over 1/5, which is equal to 5. Oh, okay. And if I plugged in like 1 over 30, that'd be 1 over 1 over 30, which would be equal to 30. So it seems like the smaller that my inputs get, the closer to 0, the bigger my outputs are getting. So this part of my graph is going up, 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 up. And we know it's not going to touch 0 because when I plug in 0, I get undefined. And so that's what that part of my graph looks like. All right, well, what about negative numbers? So it looks like if I plug in like -3, I get -1/3. So as I plug in smaller and smaller numbers over here, it's also flattening out. Touching, not touching, I don't know. We'll talk about that in a second. And then same idea, if I plug in some fractions, like -1/5, my output is going to be 1 over -1/5, which is equal to -5. So as I get closer and closer to the y-axis, this part of the graph is going down. Chelm timber. Okay, so that's kind of what my graph looks like. And we said if I plug in 0, I get undefined, and we see that my graphs, these pieces are kind of going up and down and flattening out at the y-axis there. So really what we're looking at is we have a vertical asymptote at x equals 0. So I'm going to write that down. So we have a vertical asymptote at x equals 0. Okay, now you may remember some things about vertical asymptotes from last year, but vertical asymptotes, we cannot cross those. Okay, and the reason we cannot cross the vertical asymptote is because our function is undefined at those values. So there would be no way to cross those vertical asymptotes. Okay, now it also seems like my graph's flattening out at 0, except at y equals 0 this time. And if you remember, we talked about how we could check this. I could set the whole equation equal to 0, put 0 as an output, and try to solve. How would you solve this for x? Well, you'd probably try to get rid of the fraction, so you multiply both sides by x. But 0 times x is just 0, so you get 0 equals 1. Well, 0 doesn't equal 1, which means that I can never have an output of 0, is what that means also. Okay? So these parts of my graphs, they're flattening out at the x-axis, which means there's also a horizontal asymptote at 0. So we have a horizontal asymptote at y equals 0. So y equals 0, that's the horizontal line at 0. X equals 0, that's my vertical line at 0. Okay, so this parent function has no x-intercepts, has no y-intercepts, and the reason why is because it has a horizontal asymptote at y equals 0, and has a vertical asymptote at x equals 0. Okay, so this is a little bit trickier of a parent function, but one that we have to be comfortable with, and you really need to know these features. All right, so our sixth parent function, f of x equals the square root of x. Now this one, we've talked about this here a little bit, okay? Now, again, I like to make a table anytime I'm not sure. Hopefully after today, we won't have to make so many tables because we'll kind of know what these functions look like. So the square root of x. So let's go ahead and throw in some negative numbers, some positive numbers, and see what our table looks like here. So I plug in negative 2. Square root of negative 2. Well, that's imaginary. That's not a real output value. And then same with the square root of negative 1. So looks like negative values are not in my domain. So I know when I go to graph this, if I have my xy plane here, since negative numbers are not in the domain, my entire graph is going to be over here in positive world. All right. What about 0? Square root of 0. Well, that's just 0, so that's fine, no problem there. Square root of 1 is 1. Square root of 2 is, I don't know, square root of 2. Square root of 3. Square root of 4. Well, that's equal to 2. And then these values in here we can just estimate for now. What's the square root of 2? Is it 1.2 something? I don't know. I should probably grab a calculator. 1 point something. 1 point something. Okay. So that's our table. But I think we can kind of reason through what's happening here. If I plot these points, the first point I have is at 0, 0. The second good solid point I have doesn't happen until x equals 4. 1, 2, 3, 4. And that gives me an output of 2. And then at 2 and 3, looks like we have 1, 1 is in there. And then it looks like we're just growing really slowly. And then we're not going to get all the way up until 3, until all the way at x equals 9. So this graph, if you look, it's growing pretty slow. It's getting there. It's going to keep getting bigger and bigger and bigger, but it's going to take a while to grow very quickly. So definitely not like an exponential. So it's growing very slowly, but eventually it'll get there. So our domain, what would our domain be here? Our domain would be the set of all x values such that x is greater than or equal to 0. And then what would my range be? My range would be the set of all f of x values such that f of x is greater than or equal to 0. Okay, so anything positive as terms in x and y will get covered, but no negative values, no negative outputs, no negative inputs for this guy here. It is slowly growing. It will keep growing, but not very quickly. Okay, last one. F of x equals the absolute value of x. Okay, so if you remember absolute value, we write that with these two vertical bars here. Now, can we just talk about what absolute value means before we talk about what the graph looks like? So some of you might be like, make it positive. And you're kind of right. But what does it mean if I'm looking at the absolute value of -6? What does it actually mean? So this actually means how far away is -6 from 0. So really what absolute value is answering is if I have a number line and here's 0 on the number line, how far away is the number -6 from the number 0? That's what that means. And with distance can never be negative. Distance can only be positive. So in this case, -6 would be 6 units away. So that's why the absolute value of -6 is equal to 6. Okay? And the absolute value of +6 is also equal to 6 because it's answering a similar question, how far away from 0 is +6? And the answer is it's 6 units away. So that's really what we're doing here. Okay? So if you want to try to think about it as if it's negative, you make it positive. Well, okay, that's fine. But really, it's how far away is it from 0. All right, so if you want to make a quick table here, so -3, -2, -1, 0, 1, 2, 3. So your output, if it's -3, output is 3, 2, 1, 0, 1, 2, 3. So there we go. Nothing too crazy here. So what is this going to look like on a graph? So here's my XY plane. If I wanted to graph this, so plug in -3 and I get 3. Plug in -2 and I get 2. Plug in -1, I get 1. 0, 0. Plug in 1, you get 1. Plug in 2, you get 2. Plug in 3, you get 3. And so what we get is this V shape looking graph like that. Okay, so this one might look familiar now you've seen it. You maybe saw this last year. So my absolute value graph gives me this V. And that's what we have going on. Okay? So there's our last parent function, was the absolute value of x. Okay, so now you have all those in your notes, which is great. Okay? But even better than being in your notes would be if they're in your head. So we need to have those memorized. This is one of those things where if you don't memorize them, could you still go take the test and get a decent grade? Maybe. Okay, I don't know. But if you don't have these memorized, it's going to keep biting you in the butt all this year and all next year. You have to know your parent functions. So let's do a couple practice. So I want you to close your notebook, find a scrap piece of paper here, and I want you to try to graph a couple functions for me. Okay? Ready? No peeking. So the first one I want you to graph without peeking. Go ahead and see if you can graph f of x equals x cubed. Ready? Pause. Okay. How did you do? Did you grade yourself? So, does it have to be perfect? No. Do I want you to make a table? I do not. Okay? I want key features here. So on x cubed, my key features that I need to know, it's got to go through the origin, and then we have this shape here. So for what we need, this is perfect. Okay? I don't want a bunch of points. I want quick, memorized graphs. So this is perfect. Okay? Okay, next one. No peeking. You got to be able to do this quick. Ready? I want you to graph square root of x. Ready? Pause. Okay, how did you do? So if you're going to graph this, I don't need it to be perfect. I just need to have key features. Key features, what are they? Starts at the origin, slowly grows for forever. So there's my square root of x graph. Okay, is it perfect? No. Does it have a bunch of points? Nope, but that's what I want. Okay, f of x equals x squared. Ready? Pause. Alright, so this one should have been a gimme. If you're still struggling with this one, we really need to practice. So x squared is my quadratic. So we get something that looks like that. Does it have to be perfect? Nope. Key features, hits the origin, and has this shape, this quadratic shape. Okay, last one. Ready? F of x equals 1 over x. Pause. Okay, quick. Key features. We have a vertical asymptote at 0, horizontal asymptote at 0, and then it flattens out at both of those asymptotes.